Hello, my name is Dominic Finelli, and this is my presentation for Physics 2211, Lab Number 4, Oscillations. Introduction. The goal of this lab is to observe oscillations through the movement of a block attached to a spring and compare the real-life movement to a coded model of that same movement. This lab makes use of Newton's second law and the energy principle based around the spring, block, and gravity from the Earth. Newton's second law and the energy principle. These two principles are imperatives to this lab, as Newton's second law is used to calculate the spring force, and the energy principle expresses how energy is neither created nor destroyed throughout the process of the oscillations. So here's my experiment using tracker. As you can see, the initial conditions, time is equal to 0, initial velocity is equal to 0, the initial position is slightly off from the origin. Mass is 0.402 kilograms, K is 7.01, and L naught is 1.3. Here is the coded model. This is all of the code that I changed from the starter code in order to make the coded model the same as the experiment that I did in Tracker. And here is the coded model in action. So here are the results from the coded model. As you can see, most of it was accurate. However, there were some issues with the Y position. So we can see here the change in energy makes sense. Delta E stayed roughly 0 throughout the entire experiment. However, as you can see here in the movement, there's not much change in the Y direction, which is not the same as the experiment that I did in Tracker. So the X position is pretty accurate, but Y position is pretty off. So, as you can see here, obviously here's a closer look. There's a lot of discrepancies with the Y position versus time. The peaks are opposing each other, and then the magnitude of the model is just way smaller than that of the experiment. So this is obviously just due to issues in my code. I didn't write the code that involved the Y position well enough. So that's what led to these discrepancies. What does it mean, number 1? For your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. The energy principle is satisfied as the change in energy remains at 0. As you can see in this graph, throughout the entire experiment, delta E is equal to 0, or roughly equal to 0. There were some discrepancies. However, as you can see, this orange line stays straight throughout the entire experiment, which is basically what the energy principle is saying, that the change in energy is 0 because energy is neither created nor destroyed. What does it mean, number 2? Using the data you obtained in Tracker, make 2 separate estimates of oscillation periods. First, by estimating the period of oscillations from the X position data, and second, by estimating the period of oscillation from the Y position data. Compare the 2 estimates and discuss. So, throughout the experiment, the time was 8.74 seconds, and then here the Y position had 5.75 cycles, and X position had 5.25 cycles. So then calculating the period from these, we get 1.52 seconds for the Y position and 1.66 seconds for the X position. Now this is interesting because 1.52 is the correct period for this experiment. So the fact that we had some slight discrepancies with the X position is quite interesting. Thank you so much for listening. That is all. Thank you.